Hi, hello everyone. Welcome back to my channel. In this session, we discuss about the full ladder of adder. In this introduction to full ladder and half adder, a full ladder and half adder are both digital circuits used in computer arithmetics. It will be applications of various logic diagrams will be used. Both circuits are used to add binary members. The main difference between the two is the inclusion of carry input and output in a full adder. Half adder definition and functionality. A half adder is a basic digital circuit that adds two single bit binary numbers like A and B are the two single bits and S will be the sum, it will be output. A and B are the two inputs and sum will be the output, and carry also be the output. The sum output represent the least significant bit of the addition result, while the carry output represent the carry out. Then next half adder, it will be the truth table of the half adder. The sum output is XOR exclusively OR of the two inputs A and B, and the carry output is AND of the two inputs A and B. The truth table of half adder consists of all possible combinations A and B with their corresponding sum and outputs. Input like A and B, outputs are sum and B. Like A is 0, B is 0, then sum is 0, carry is also 0. A is 0, B is 1, then sum is 1, carry is 0. Like A is 1, B is 0, sum is 1, then carry is 0. 1 1 1 1, it means the adding of A and B value. 1 0 1 means it means 0 will be the sum, 1 will be the carry. Next, the half adder circuit diagram. The circuit diagram of half adder consists of an XOR gate of for some output and gates, some out and gate for the carry output. The inputs A and B are connected. Both gates and outputs are obtained accordingly. The half adder circuit it simply doesn't include any carry input or output. Like that only in the previous slide we explain about the two table of the half adder. Then next we full adder definition and functionality. A full adder is an extension of an half adder that includes additional carry input and carry outputs. It can be three inputs and two outputs will be used in the full adder. The output of the full adder are the sum and the carry out. The we see that the slide of in front of you, the logic gates will be used to build the circuit. Also the full adder truth table of full adder consists of all possible combinations A and B, and carry means C in value along their corresponding sum and carry outputs. The sum output is obtained XORing three inputs A and B and carry in values. Also the carry out is generated by the combination of AND OR operation on three inputs. In that full adder circuit diagram, the circuit diagram of full adder is more complex than half adder due to inclusion of the carry input. It consists of two XOR gates and two AND gates and OR gate. The inputs A and B carry in values connected to these gates obtain the sum and carry out. Then the comparison of half adder and full adder means the main difference between half adder and full adder is the inclusion carry input and output of full adder. It means the in that half adder we use only two inputs and is both the same of outputs. Two outputs will use both the full adder and half adder. Like that only difference in the only inputs. In that two inputs will use, in the full adder three inputs will be used, while a half adder can only add two single bits. Means it means like that only the full adder circuit is more complex compared to the half adder. In we see the front of the circuit diagram, see small difference between the half adder and full adder. applications of half adder and full adder. Half adder are used basic building blocks in large arithmetic circuits, and full adder are essential in adding multi-bit binary numbers and carry propagations. Both circuits are widely used in computer system and digital electronics. Like that, conclusion: half adder. In summer, half adder basic circuit that adds two single bit binary numbers, while a full adder is extension that adds three single bit numbers. The main difference is inclusion of carry input output in a full adder. Both circuits have important applications in computer arithmetic and digital systems. Conclusion references like that. Thank you.